3.5 is all about proving lines are parallel. You'll want to get this stuff down in your notes. So open up your table of contents. This is section 3.5 in your textbook. So our goals for these couple of videos. First, you'll be able to work with the converse of the parallel lines postulate and theorems. We'll talk about that. Next, you'll be able to put together some flow proofs for these theorems. And then finally, you'll be able to construct parallel lines using corresponding angles and alternate interior angles. We're actually going to start with that last learning target in just a sec. So recall section 3.2. The theorems we had started with our postulate. If we have two parallel lines cut by a transversal, then corresponding angles are congruent. We proved several theorems involving that. One of them was if we had parallel lines, then alternate interior angles were congruent. We also proved that if two lines were parallel, alternate exterior angles were congruent. And lastly, if two parallel lines are cut by a transversal, then consecutive interior angles are supplementary. So what section 3.5 does is it takes and turns those around. In other words, it's the converse of the 3.2 theorems. Now our postulate says if corresponding angles are congruent, then lines are parallel. And these theorems that we'll prove using that postulate follow the same kind of vein, right? If we have alternate interior angles that are congruent, then lines are parallel. Alternate exteriors give us parallel lines. Consecutive interior angles that are supplementary give us parallel lines. And then that last one, if two lines are perpendicular to the same line, then those lines are parallel. We'll talk about these, and we'll actually prove most, if not all, of these theorems. But first, let's take a look at that postulate. So that postulate, if corresponding angles are congruent, then lines are parallel. What we'll do first is we'll justify this postulate with a compass and straight edge construction. So once again, you'll want to get this down in your notes, pull out your compass and straight edge, and follow along. Video showing the same kind of construction using GeoGebra. First off, let's right-click on the graphics pane and turn off the axes. And then we want our initial points for a line, and then a point not on the line. So first step was to connect that that point through that line. It doesn't matter if it's exactly through A, but we'll just do that for sake of clarity. Let's move these labels off to the side a bit. Now our job is to copy this angle up top here. Now we've got this tool called angle. We're going to first use it to measure angle BAC. And we can see the angle, it's called alpha, is 61.4 degrees. And we want to copy that angle using C as a vertex. So in order to do that, first we need a point above C on that line, line B I guess it's called. And then, let me just move that label. Then we're going to copy the angle using the angle with given size tool. So if you look at the help text, it says select leg point, then vertex, and enter size. So I'm going to select leg point, vertex, and then it asks me to enter a size. Well, I'm going to enter alpha, right? So I'm going to tie this angle to the previous angle. And now I want the angle to fall from D, so that's in a clockwise fashion. And so then I'll connect C through that point that's created, called D with the apostrophe, would be called D prime. And now we've created parallel lines that are tied together using corresponding angles. And again, we can check using the drag test that each of the very dark blue points we can move and the construction holds together.